All right, so let's do this diverging mirror example here. This is from your assignment. And the three rules for diverging mirrors, as we just talked about, are exactly the same with diverging and converging. Okay? Parallel, as if through the focus. That's the only difference for diverging, as if through the focus. And then as if through the focus, parallel, right? And then center bounces right back. So let's take a look at each one of these. So for this one right here, you're always going to start at the top of the object. Okay, this is O. You're going to start with your pencil at the top of the object, and you're going to make a parallel line with the principal axis, just like you did with the other ones. And again, this is my best freehand parallel line. You're going to use your ruler so it's perfect. That's not perfect enough for me. That's perfecter. Okay, so parallel line, where it hits the mirror, okay, where it hits the mirror, you're going to draw a line connecting this point and your focus behind the mirror. So remember, with diverging mirrors, the principal focus is behind the mirror. Because why is that? Well, here's the center of curvature. What does that mean? Well, the mirror bends this way so that this is the center, right? So if it's bending this way, the center is not over here because it's not bending this way, it's bending the other way. So the center has to be over there. And the focus then has to be over there, okay? So it should totally make sense if you just think it through. The principal focus has to be on the back side of the mirror there. All right, so as if through the focus. So parallel, focus, no problem. Dotted on this side of the mirror, right? Dotted here. And then you can go ahead and extend that in a solid line this way. Nice. So diverging mirror, this light ray definitely diverges away from the object, diverges away. Now, second rule. Focus, parallel, or as if through the focus, bounces parallel. No problem. Here's focus. You take your pen and your ruler, and you would connect those 2 points. And we're going to do this. We're going to draw a solid line on this side of the mirror, just up to the mirror. Oh, where'd it go? Whoa, where'd it go? Computers are not liking me these days. Really? I just drew that. It just disappeared. Don't be stubborn. Okay, so as if through the focus. Now, remember, we do not extend ever the initial ray to the mirror. We always extend the reflected. So the reflected ray is going to be parallel. Okay, good, we got that. These two rays are never going to meet on this side of the mirror. We can see that. They're never going to meet. They are diverging. So I need to extend the reflected ray behind the mirror. Look at that. Now we have light rays intersecting, even though it's virtual. What this means is that because these light rays came from the tip of the object, these light rays represent the tip of the image, and the image should be dotted. I know it's a little hard to see there. I'm going to zoom in a bit. Okay. It's going to be like super zoomed in. Not going to be super friendly, but so here's the tip of the image, dotted. Okay. Now, I drew the image there because that's really all I need. Now, the third rule, though, for confirmation, right? From the tip of the object, now draw a straight line to the center. Solid on this part, in front of the mirror. And it's reflected back along the same path, so I can extend the reflected ray as if through the center. Wow, a little bit off, but freehand. Okay, and look at that. They would all meet at the same spot right there. So that's the tip of your image there for this diverging. Okay? So a couple things to remember. The same rules for diverging mirrors as converging, except the focus and the center are going to be behind the mirror, and the rays in the front of the mirror for diverging are going to diverge. That's a shocker. And so what you extend is you extend the reflected rays as dotted lines behind the mirror, and they should meet back there somewhere. Okay? Now, there will be special cases where the light rays will be parallel both in the front and the back, if, you know, there are some special situations, but for 99% of your diagrams, they're going to meet somewhere, either in front or behind. So here we go. There's converging, and here is, of course, diverging.